Right, here's the other big topic in chapter 6.8, part 1. We had been talking about when we were integrating horizontally to infinity, but now let's talk about what happens when the function values itself goes to infinity, even if the range of the domain of integration is finite. But let's think about this. The integral from 0 to 1, 1 over x squared, looks like this. As x gets close to 0, 1 over x squared shoots off to infinity. We saw that integrating this from 1 to infinity was a convergent integral and actually had a value of 1. The area under the curve all the way out to infinity horizontally was 1. So the big question is what's going to happen here? So what can we do? Let's do the indefinite integral maybe. So 1 over x squared dx. You could write that as x to the negative 2 dx. And we'll get x to the negative 1 over like that. And then try plugging in stuff. So try the integral from 0 to 1. So that would give us minus x to the minus 1 from 0 to 1. We'll move the minus out front and we'll plug in 1. So we get 1 to the negative 1 minus 0 to the negative 1, which is 1 over 1 minus 1 over 0. Do you see any danger spots here? Yeah, dividing by 0 is going to be a problem. So what do we say about that? What is 1 over 0? It's undefined. Well, maybe if we're a little more careful about it, we can figure out what it's sneaking up on. We'll take a more careful approach and say, instead of integral 0 to 1, what was causing the problem here? It was plugging in that 0. So let's say we're going to take the limit from a to 1, and a will be things that aren't quite 0 but are sneaking up on 0. So we'll say take the limit as a goes to 0 of 1 over x squared dx. So we'll say that's the limit as a goes to 0. We'll put the minus out here, just like we did there. So we'll get x to the negative 1 from a to 1. Say limit as a goes to 0. Now we can plug in the 1, so we get 1 to the negative 1 minus a to the negative 1. So we can say 1 over 1 minus 1 over a. And now, what's the limit as a goes to 0 of 1 over a? Well, we're saying, so we'll just copy the 1 there. So we're saying plug in like 0.1. What's 1 over 0.1? 10. Try plugging in 0.01. What's 1 over 0.01? 100. Try plugging in 0.001. You get 1,000 and so forth. So you're getting infinity there. So that whole thing is going to give you infinity, which means the limit does not exist. So the area under this curve that's an infinite area, which kind of makes sense because this function is zooming off to infinity, right? How could you integrate something whose y values are zooming off to infinity but still get a finite area? Seems impossible. But the other time back before, when we were integrating to horizontal infinity, there we integrated to horizontal infinity 1 over x squared and we got a finite answer. So maybe our intuition needs to be retrained. Let's try another problem. Let's try the integral 0 to 1 over root x dx. So go ahead and use the things you just learned in this part of the video and pause the video, write out stuff and see what you come up with. I'll write it out too. Let's first do the indefinite integral. It's x to the negative half. So that's x to the positive half, 1 over positive half. So now try plugging stuff in, see what you get. So we'll say limit as a goes to 0. of 1 over 0.5x to the 0.5 from a to 1, just like we did up here. And we'll say that's 1 over 0.5, 1 to the 0.5, minus 1 over 0.5. Just imagine plugging in 0 there. So what is 1 to the 0.5? 1 to the any simple constant number is just 1. This is a 2. That's a 2. And then what's 0 to the 0.5? Well, remember 0.5 is the same as taking the square root. So this is saying square root of 0. What number when you multiply by itself gives 0? That's 0. Some people get kind of make it too complicated and say the square root of 0 is undefined, but no, the square root of 0 is 0. So altogether, this just equals 2. We didn't get any infinities, we didn't get any divide by zeros. So the area under the curve from of 1 over root x, that area is 2, where the area under 1 over x squared was infinity. So apparently you can integrate something whose values are going off to infinity and still get a finite value. Interesting. One other little thing to wrap up there. What if you were integrating across a vertical asymptote, not just stopping at a vertical asymptote? So what if the vertical asymptote is inside the limit, the domain of integration? So for example, if you had integral 0 to 10, 1 over x minus 4 dx, the first thing I would do is graph it. If you plug in x equals 4, you get divided by 0. So here at 4, you're going to have stuff basically behaving like 1 over x. It's just shifted over by 4. So we'll have something like this, and something like this, and you're integrating all the way out here to 10, starting at 0. And so what you have to do there is break the integration at wherever the divide by 0 or whatever other issue you're having is. So you have to split the integral at the vertical asymptote. So here we go with integral 0 to 4, 1 over x minus 4 dx, and integral from 4 to 10, 1 over x minus 4 dx. And then you have to have both of those things exist to be allowed to add them together. So both of those integrals have to be convergent. For the original integral to be convergent. And if they are, then you can add them together, and that's the value of your integral.